This is an example calculating the Fourier series for figure A from problem 3.22 in Oppenheim and Wilsky that we had as a in-class activity. Here I've roughly sketched the signal. It's t for t between -1 and 1, and then it repeats over the next, indefinitely in both directions. So the period for this signal, cap t, is equal to 2. And we can first notice that A sub 0, the DC level, is going to be 0 for this signal because it's equal parts above the 0 line and below the 0 line. So A sub 0 equals 0. And then we have to compute the other A sub k's. And as I indicated in the title here, this will require integration by parts. So the definition for A sub k is going to be, again, 1 over t integral over t period x of t e to the minus j k omega naught t dt. So now, plugging into our equation here, we have 1 over 2, and we're going to integrate from -1 to 1 because that's the easiest definition for our signal. So integral from -1 to 1, and the definition of x in that interval is t. So it's t times e to the minus j k. Omega naught is 2 pi over cap t. Cap t is 2, so omega naught is pi t dt. And I'll write up here omega naught equals pi. Alright, now we're going to shift down. Hang on a sec here. There we go. Sorry. There we go. Alright, now, again, as I said, this will require integration by parts. So I have to identify, again, definition of integration by parts. If you have u integral of u dv, that's equal to the integral equal to u times v minus the integral of v du. So in order to do this, we have to identify what our u and our v are. Alright, so the easiest thing is to call this u and call this part dv. So then du will equal dt, and v is going to equal negative 1 over j k pi e to the minus j k pi t. Alright, so now, again, this is not, in this case, this is a definite integral, so we have to evaluate everything. So in our case now, we have a sub k equals t times our v, which is negative 1 over j k pi e to the minus j k pi t. But now we have to evaluate that from -1 to 1. Then we're going to subtract from that the integral from -1 to 1 of v du. And again, du is just dt, v is negative 1 over j k pi e to the minus j k pi t, and then dt. Alright, so now, move this up a little bit again. Now I have to evaluate this. So evaluating it at the upper limit, I'm sorry, I forgot a very important thing here. We have to have 1 over t, which is 2, times this whole thing. Otherwise I'll mess up. Alright, so now, evaluating it at the upper limit, we put the 1/2 out front, and we have 1 times negative 1 e to the j k pi. So negative 1 over j k pi in front of e to the minus j k pi. and subtract from that t evaluated at minus 1, minus a minus is a plus, negative 1 over j k pi e. Now again, t is negative 1, so that cancels that, so now we have a positive exponent. E is positive j k pi. And now we have our integral here. So we have minus the quantity. And again, integrating this will give us basically this squared, which becomes now negative 1 over k squared pi squared e to the minus j k pi t evaluated from minus 1 to 1. Put the parentheses around here and then close the brackets. Alright, now this next step we have to look at what we have here. E to the minus jk pi. If you think about the unit circle, pi is right there. That's negative 1. E to the positive jk pi. Actually, this is e to the positive jk pi. E to the negative jk pi would be exactly the same point. So this is equal to, and again, it's got a k in there. So again, if we go e to the minus jk pi, you go around here. E to the minus jk 2 pi brings you to here. 3 pi would be back to here. 4 pi to here. So this becomes minus 1 to the k. And we have the minus 1 over jk pi in front. And I'm going to put a parentheses around this because I have the same thing here and here. Plus minus 1 to the k. They're the same. So they add. So I could just put 1 here, and I'll put a 2 out here eventually here. Alright, now the second term. When I evaluate this at t, we have, again, putting this term out front, we have plus negative 1, plus 1, sorry, over k squared pi squared times e to the minus j k pi minus e to the positive j k pi, and then this whole thing again is multiplied by 1/2. Close the brackets. Alright, unlike this though, where they added, here I have negative 1 to the k minus negative 1 to the k. So these actually subtract from each other, and this whole term goes to 0. So I'm left with, move it down a little bit, again, I'm combining these to put a 2 here. This 2 will cancel with that 2. I end up with negative 1 over j k pi, and this whole term is 0. So this is in fact my x of t. And the only other thing I could do, a sub k, and the only other thing I could do is bring the j out of the denominator if I want. So if I did that, it would end up being j over k pi, and that's for k not equal to 0, and that's it.